welcome back. This is Hector from HelpMeGraduate.com, and we're going to talk a little bit about functions. We're going to give an initial introduction on what is going to be the main topic in the upcoming videos, okay? And a lot of people hear the word functions or read functions in books and notebooks and their program when they go into college or math classes, and they kind of freak out because, functions, the word is kind of scary, to an extent, and the fact that that you're dealing with stuff like y equals f of x, and there's like a bunch of operations going on to x, that kind of scares people a little bit. And it's okay, it's normal. Initially, the first time that I saw functions, I didn't quite understand what was happening, okay? And the way that it's explained in some classes may be a little bit confusing. So I just want to think of a function of something that is doing certain operations to a certain variable, okay? It's just something like this. So let's say we have two sets, and one set is what we call, let's call it set A, and we're gonna rename it later, okay? And inside A we have a bunch of things. These things in math are going to be most likely numbers, okay? Any number like 0, minus 1, minus 300, 400, 5,900,000, 87, and so on, okay? I have a bunch of numbers, and that numbers is, my A domain. It's my initial set of elements. And to those elements, I'm going to do certain things, okay? And those things that I do is what I call the function, okay? And that transformation, which I'm going to label f, it's what is called the function. So after I do the transformations to my numbers, then I get a second set of elements, which I'm going to call set b, okay? Now, A and B, as you may have heard, they're sets, right? So they have names, they have specific names or labels that are assigned to them, okay? And set A, I'm going to rename it to be known as domain of f, okay? Domain of the function f. And B, I'm going to rename as the set called range of the function f, okay? So in essence, domain of f is all the elements that I want to work with, okay? It's just as simple as that. The domain of the function f is all the elements that I want to work with, or that I'm going to be working with, okay? The function is the operation that I perform to those elements, and the range is the result of the operations of working with the domain, okay? It's just as simple as that. So imagine for a second that I have, for instance, let's say a bottle, and this bottle has water. Let's say a bottle of water, okay? And it's just an empty, unlabeled bottle of water, okay? So if I put this bottle in an assembly line or whatever, okay, I'm gonna have to need a label, okay? A label. Let's say the label has a reading and a nice logo and something like that, okay? Something pretty nice, I'm not very good at drawing. So when I put the bottle into the assembly line, the result is going to be the bottle with the label, okay? The bottle with the label. And of course the water inside. Okay? So what happened here is something very similar to what happens in math with functions. I had something that I had to work on, okay? I had an assembly line that I had to do something to that main element, and then I have the result. Well, this is exactly the same thing, okay? I have my raw material here, I have the function, the operation, and then the result, okay? It's just as simple as that. There's an example I'm going to bring up. Let's say a simple example, a quadratic function, and we're going to deal with that in another video. Let's say we have 3x squared, let's do something like 3x squared plus x minus 2. Okay? So it's just as simple as that, okay? I have a bunch of numbers, and the numbers are like all across, the universe. They're the real numbers. So when I have that number, here's the function, okay? And the result is going to be what is called y, okay? And that's where you associate the xy table to kind of plot the numbers, right? Okay? So here's my raw material, 0, 1, 2, -1, and so on. And here's the result of it, what happens when I do 0 here, 1 here, and so on, okay? So you may be wondering, well, why do I need that? You know, why do I need functions in life in general, you know? And well, functions are pretty much everywhere in life, okay? Almost everything you can think of is normally a function, okay? From the signal that's going to your cable antenna, or the amount of water that goes through your water pipe, everything is pretty much a function. And you know, there's engineers that needs to know function, there's business administration people that need to know functions, statistics, everyone, you know, there's a lot of people that is involved with it, okay? So what we're going to learn in the subsequent videos is an immediate, straightforward method to try to learn about functions as quick as possible and understand the different types of functions that they are and how are you able to graph them, okay? Like for instance, if I was to graph this function, okay, most people would start plotting numbers right away, okay? Let's plot 0, 1, -2, -3, 2, 3, 4, and then they have like 5 or 10 numbers and then they do the plot, okay? But in reality, when you become real good, when you have, you know, acquire a certain level of practice with functions, you just see a function and you just graph it without plotting, okay? And I'm going to show you real quick, okay? Let's do it without the plotting. Let's say we have 3x² plus x minus 2, okay? This is what is called a quadratic function, right? We heard that term before, quadratic function. So we know that the graph of the quadratic function is pretty much, you know, something like this or like this, okay? So it's only have like two choices. It can either be like this or it can either be like this, okay? So the sign of the constant backing up the variable with the highest degree tells me whether the function is opening up or opening down. Where's the concavity of the function in this case, okay? The fact that it's positive, because right here is +3, tells me that it's opening up, okay? So when I go to the axis, I maybe need a couple of few more things to do the graph. And what is that? Well, when I have the axis yx, I know that this function is opening up because +3 is telling me that. What I would like to know is where exactly would it be opening, okay? It's kind of puzzling where it is. Well, here's where 3 things take place, okay? Number 1, the cut or the intercept of the function with the x-axis. Number 2, the cut of the function with the y-axis. And number 3, the zeros of the function, which is essentially what I said before, okay? So once I'm able to find those coordinates, I'll be able to tell where pretty much the function is, okay? And to find the cut with y, to find cut with the y-axis, all I need to do is make x equals 0, okay? Because if I want to find where the function is cutting this axis, it means that the value of x is 0, okay? Because this value right here is 0, okay? On the x point of view, this is just 0, okay? So if I make x equals 0, in this particular case, I'm going to be left with 0 squared goes away, 0, 0 goes away. I'm going to be left with -2. Okay, so for x equals 0, in this particular case, I have y equals -2. So it means that the intercept with the y-axis happens here, -2. Okay, so now I know another thing about the function. The function, not only its concavity is going up, it's opening north, but it's also cutting the y-axis here. So I know it's going to be somewhere around here, right? It's going to be something like this. Well, but you may ask, how are you sure that it cuts the x-axis in those 2 points? Okay, that's a very fair question, right? Well, to do that, I need to know where the function is cutting the x-axis, and to do that, that means that y equals 0. Or in other words, that this value right here, this value right here of height, it's exactly 0. Okay? It's just as simple as that. So again, let's do another note to find cut or the intercept with x-axis. All we have to do is y equals 0. Okay? And in this case, if y equals 0, okay, that means that we have to solve the quadratic formula for this equation, okay? And I'm going to delete this, erase this, and after fractioning and doing, rationalizing, you're going to end up seeing that 0, which is, what I want to do, y equals, it's going to be 3x minus 2, x plus 1. And that means that there are two cuts in the x-axis. One is at 2/3 and the other one is at -1. So I may just fix a little bit this, or I may just write it down, and then I know that this cut right here is -1, and then this cut right here is 2/3. See? That's it. I just have to do 1, 2, 3 things to plot the entire graph. I don't have to do anything else. I have to do the crazy table thing with the plotting, because I know that quadratic functions have concavity. They open up pretty much like this, and they can either go up or down. Once I located the cut, the intercept with the y-axis, and the cut, the intercept with the x-axis, and the sign to know which way it opens, the rest is just graph. Okay? I may be, of course, a little bit off with the values exactly, but pretty much the graph of the function is there. Okay? That's undeniable. We'll work about it, a little bit more about it in the next videos. Okay?